Welcome to the StructSoftCentre community.
So first of all, on behalf of StructSoftCentre, I would like to welcome you all guys in this introductory session for the upcoming live training program under the title of Complete Reinforced Concrete Structure Design by using CSI ETABS, STAD RCDC and Advanced Excel. Here I am expecting that you all attenders are belonging to different fields of civil engineering, means you are having different nature of work profile. So very first thing I am here expecting that the category first, as many of you are pursuing your bachelor's or master's and your interest is in the subject of structural analysis, in the subject of structural design, and with that interest you would like to become a professional structural engineer and wanted to make your career in the field of structural design, and with the intention that you will learn some real things from the training, you are coming here to watch this demo session. And the second category, I am expecting that many of you are working professional, but you are working on site, and now you would like to change your work profile from the site engineer to the design engineer. After having lots of experience on field, now you want to change your career from site engineer to the design engineer. That may be the intention, and with that you are coming here. And the third category, I am expecting that the people, those who are new in the field of structural design, they might have learned the design from the different platforms and they are not having that much confidence to deal the real example projects on their own. They are facing lots of challenges to do the design, to do the analysis, to do the detailing, to do the optimization, and they are doing the mistakes while completing their projects. So that I am expecting the third category. And the fourth category, here I am expecting that the people, those who are having lots of experience of the design, they are having the experience of designing the structure about 10 years, 15 years, 20 years or more than of 20 years. But the problem is that they are doing the design with the conventional approach. They are going to do the design by manual approach. They are using the old softwares, 2D softwares. Now their intention is to upgrade themselves with the trending software, with the trending practice nowadays by the experts. So these four categories I am expecting actually present here, and their intention is to learn something new, to upgrade themselves. So simple question I would like to ask with you all, please let me know from which category you are belonging, so I can understand your level. So accordingly we are going to do the further discussion. So just let me know from which category you are belonging. Either you are belonging from the first category, second category, third category or fourth category. Just write in the chat box, please. Hurry up, hurry up. I just want to see from which category you are belonging. Okay. Most of you are responding. Abdullah Ahmad from the category 2. Okay, fine. Ramesh, category 3. Hurry up. Pawan from the category first. Okay, fine. Sonali from the category 3. Hurry up. I'm just looking at your response. Please guys, as I told you, during this interaction I would like to ask few of the questions so I can understand the things betterly. Okay. Pujasri, category 2. Manohar from the category 2. Okay. So here I am considering that you all are belonging to all of these categories. Okay. Thank you very much you all for your response. Now next important thing we need to understand, if suppose you want to become a professional structural engineer, so what things are essential? What are the important things on which the career of any structural engineer is depend. So amongst them, very first thing is knowing the design software. As per the current scenario, as per the market demand, if suppose you are going to approach for the job or to work, they first going to ask a question, how many softwares you are knowing, how effectively you can handle the software, how smartly you can control the software. That is the first question. And the second important thing is having the knowledge of the structural concepts, basic concepts. Some advanced concepts are very essential. Software is just a tool. Without of means software is just a calci. If you are giving the wrong input, your calci is going to give your wrong output. Likewise your software is, if you are giving the wrong input, you will get the wrong output. If you are giving the right input, software will give the right output. So how you can validate the software? It is important to have the basic concept knowledge of structural design. And the third important thing is having the knowledge of your design code. And the fourth important thing is your experience to deal the real example projects. We will discuss all of these requirements in detail one by one. So let's talk about the design software. So in market, if you are going to look at, so there are many softwares available. So people, what they are doing the mistake, they are trying to learn all of these softwares. That is totally wrong. It depends on your interest, what type of structure you are going to design, what type of structure you are going to deal with, and based on that you have to choose the particular software, and that software only you need to learn. If suppose you want to design the RCC structure, so nowadays well commonly used software is your CSI ETABS software for the low rise, for the medium rise, for the tall structure. Most of the iconic structures of the world nowadays were analyzed and designed by your CSI ETABS software. Then Stat Pro software is also there. It is having another application. CSI Safe software for the substructure design. CSI Bridge is there. SAP 2000 is there. Tekla structure is there. MADAS is there. So there are so many different softwares available in market. You have to find which software will suit your work, your demand, and as per the industry demand. And that software only you need to learn. You need to get the command over that particular software. If suppose you are going to do the detailing, so well known software for the purpose of detailing, scheduling, bar bending schedule, bill of quantities, that all things you will get from the STAT RCDC software. You need to learn this software. You should have the command over the Excel sheets to deal each individual elements. So without of learning of the softwares, without of getting the skill over the software, without of getting the command over the software, you cannot survive in the market. So very first requirement, very first need is about your software. Hope that you all agree with this. Now the second requirement is structural concepts. If your base is not strong, you cannot effectively use the software, even you will not able to use the software. So what are the different elements? What are different types of the loads? What are the different types of the structure? What are the different types of the structural configurations? How your structure is going to respond under the gravitational loading, under the lateral loading, under the temperature loading? What are the different methods of analysis? Static analysis, dynamic analysis, speed delta analysis, modal analysis, buckling analysis, stress analysis. What does mean these all different methods of analysis, and what will be its design, its analysis output? What are the different material properties? What are the different types of the beams, columns, the basic concepts? What is the earthquake loading? What is the basic calculation, hand calculation for the static, for the dynamic? Software, again I am repeating, software is just a tool made by the humans, and while making the software these basic concepts were applied. But if your basic concept is not strong, there will be no use of this software. Anyone can handle the software, that is a clerical work. You have to learn about the software. You need to learn about the concepts, then only you have to go for the software. So this is the second important requirement. You have to think about this. And the third important requirement is about the design code. Without following the design code, you cannot do the design as stable. You cannot able to design the structure as serviceable. You will not able to design your structure as economical. If you are going to do the design your structure without following the IS code, you will end up with the uneconomical design, unstable design, and your serviceability will not be effective. We cannot rely for the serviceability of your structure. So what are the different codes available for the purpose of designing, for the purpose of loading, for the purpose of designing the superstructure, for the purpose of designing the substructure, for the load application, okay, for the stability checks, low rise, medium rise, high rise structure, for the detailing purpose, what codes are available, that all you need to learn, you need to understand. Each and every clauses you have to read and then have to implement in the software. Then in software as well, we have to validate whether the softwares are following these design codes or not. This will be the way of learning about the software. By just learning the software about the modeling, analysis and design is not the way. You need to implement each and every clauses of the IS codes. IS 456, the basic code for the RCC structure design. IS 800 2007, the basic code for steel structure design. IS 875 part 1, part 2, part 3 for the loading of the gravitational load, for the loading of the lateral load. What does mean by the live load reduction factor for the tall structure? What is the ductile detailing? Water resisting structure, water containers. So these all things we have to learn in reference of your IS code. If you are going to follow the IS code, your structure will be economical as well as stable. Without following the structure, without following the IS code, you are going to harm to your structure as well as the people, those who are going to live in that structure. That is very important. If you are going to drive over a road without following the rules and regulations of the traffic, you are going to do the accident, and due to that you are going to be affected, and the people, innocent people, is also going to be affected. The same thing is actually in the field of structural design is applicable. If you are not going to follow the IS code, you are going to what harm the structure, and you are going to harm the people, those who are going to live in that structure. It's very important, and it's very important to look at this matter. So the design code. And the fourth important requirement, you all will agree, if you are going to ask for the job, they are asking about the experience. And experience doesn't mean to count the number of years. It is the myth. We are counting the number of years. No, it is actually, we have to, the people are asking how many real example projects you have completed on your own. That is actually going to count as your experience. How many real projects, how many number of levels you have dealt in your career, what challenges you were faced, what type of project you have completed. Because when you are going to deal with the real example projects, real questions will be there, real challenges will be there, real problems will be there. Many of the questions will be there, like how to read the architectural drawing. Every architectural drawing will be different. Every structure, every project will have the unique challenges, unique problems, unique questions will be there. So how to read the architectural drawing? What does mean the preliminary sizes of the different structural elements, and how to decide that? At the initial stage, we have to decide the preliminary sizes. So on what basis you will decide the preliminary size of the beam, column, slab, footing, shear wall, and all the different structural elements? On preliminary stage, what material we should have to choose? On preliminary stage, we have to decide the loading consideration. then we have to do the analysis. And if you are going to take the help of any software, so how to handle that particular software smartly and effectively for the analysis, for the modeling, for the definition, for the design. Here it is important to understand the particular software. And software is just not to handling by over the command. You need to understand the algorithm of the software. What does mean the algorithm? Algorithm is the step that the software is going to follow to deal your project, to design your project, to design your structure. As we are human beings going to do the design a particular column, so we are following some steps to do the design. Likewise, your software is also having some steps to follow to do the design. So you need to understand that steps. That is nothing but the algorithm. What is the logic of your software to deal the project? That is needed to learn. Static analysis, dynamic analysis. From all of our social media platforms, the people are most of the time asking when to consider the static analysis, when to consider the dynamic analysis. So on what basis the decision of static analysis, dynamic analysis is dependent, you need to learn that. People are asking the question, sir, on the top floor we are getting the more reinforcement, on the lower floor we are getting the less reinforcement. Why it is happening? This is the most common thing, but why it is happening, that is needed to learn. People are asking, sir, we are going to deal with the G+2 floor building and the size of the column required to provide as 230 by 800 mm. It is totally unpredictable and unexpected. It is not required for G+2 floor building, residential building, 230 by 800 mm size. It is not possible at all. Why it is required? Because you are doing the wrong thing for the modeling, for the analysis, for the framing. You are not understanding the basic concept as well as you are not understanding about the software, about its algorithm. That's why you are facing this problem. You might have learned from the different platforms. So you are not getting the confidence, you are not getting the proper steps to do the design, to operate over the software. How to do the scheduling and detailing effectively by manual approach, by the software approach. If suppose you are going to use the RCDC software, then how to handle this RCDC software for effective approach. Most of the time the participants and students are complaining that, sir, results are not matching between the RCDC and between the ETABS software. So they are not knowing about how to control the results. There is a problem. How to do the calculation for the earthquake loading, how to do the calculation for the wind loading, for the tall structure. For the medium rise structure, for the low rise structure, it is easy. But for the tall structure, how to deal it? If you are going to deal for the tall structure, how to perform the stability checks for the torsional irregularity, for the in-plan irregularity, for overheight irregularity, for the lateral deflection, for the lateral drift, maximum minimum deflection, buckling analysis test. So these all things very important to perform. And what type of foundation will be suitable for your proposed structure based on the existing soil properties and condition. So these all are make you a confident structural engineer to deal the real example project. And if you are confident with all of these questions, you are able to complete this complete your project with all of these problems. Then only that is going to be counted as an experienced structural engineer. But if you are just dealing with the dummy project, simple building, okay, so that is not going to be counted as your experience. Hope that you all agree with this. So these four things are very much important. If you are good in these all four areas, four requirements, then only you can say that, yeah, I am ready to go to work in any of the MNC, in any of the design firm, in any of the consultancy as a professional structural engineer. But if you are weak in all of these areas or in any of these one areas, then you had to get the skill over that. You need to look at that matter. So I just want to ask a simple question with you all guys. Just please let me know, do you have the command over all of these four requirements? Just write in the chat box, please, all of you. Write in the chat box and let me know, do you have the command over all of these four requirements? Manish, you are saying as no. Okay, no problem. Yes, just write in. Vikas, do you have the command over all of these four requirements? Just let me know, please. No, Ariz, no. Okay, okay, okay. Ashok, no. Salman, yes, that's a good thing. Ashok, yes, okay. Anshu, no, no. Raju, no. Just please respond to my question. Do you have the command over all of these four requirements? Jafar Sheikh, yes. Mazhar, Kamu, yes. Okay, okay. Pawan say no, no. Mustafa say no. Okay, okay. So thank you very much you all for your response. Those who are having the knowledge and commands over all of these four requirements, that's a good thing. But those who are not having the knowledge, command or all of these four requirements, or any of these one requirement, two requirement, they don't need to worry about. Okay, because we are coming up with this training program, and this complete training program were designed to cover all of these four requirements. Your all of these four requirements are going to be covered with this training program. We are going to cover here all about the design software from basic to its advanced. We are going to cover everything from the basic concepts. Everything in this training program we are going to do in the light of the codal recommendation of your IS 456, of your IS 1893, IS 16700. All of the possible codes we are going to cover in this training program. And guys, in this training program we are going to take a take a real example projects. So with that real example projects, you are going to deal the complete project will with all of these real challenges, real problems. So these all things is going to be covered with this training program, and this training program will be suitable for all these four categories of the engineers: those who are pursuing their bachelor's and masters, those who are working on site, those who are new in the field of structural design, those who are having the experience. For all of them this training program is going to help a lot. Now, without of wasting time, we are finally going to talk about what will be the content of this complete training program. So this complete training program we were scheduled in three levels, as beginner level, intermediate level and advanced level. These are the chapters of this training program. People sometimes getting confused. This is the beginner level is the one training, intermediate level is the one training, advanced level is the one training. No, these all three levels are going to be covered in this training program only. These are the chapters. We were scheduled everything in a sequence way. So in the beginner level, the objective of the beginner level is to make the confidence in our participants to deal the software, to have the basic concept of structure design. So whatever the things we are going to deal in our intermediate level, we are making the preparation in the beginner level. So in the beginner level, we are first going to understand about the introduction of your introduction about your ETABS software. So very first thing is to understand the user interface. If you are not able to understand the user interface, the operating system of the software, you cannot effectively deal the real example projects. You cannot effectively complete your problems. So you have to understand how to operate your software. Secondly, we are going to take the simple projects, small elements, small tools, small elements we are going to analyze and design in the software, with an objective to validate the software whether the software is giving the right result or not. And along with that we are going to learn many of the things: global access system, local access system, okay, natural access system, load application as the point load, uniformly distributed load, area load, partly uniformly distributed load, the stress distribution, moment about major axis, minor axis, shear force about major axis, minor axis, what is the concept of major axis, minor axis. Everything we are going to learn in detail, so making the confidence in all of our participants. Thereafter we are going to dive deep into understanding of the tools of the software. in that very first thing about the file formats of the software, $et file format, edb file format, ebk file format, what are the application of these different file formats of the ETABS software, what does mean the quick access bar. If suppose you are going to do the modeling, if you are facing any problem in your modeling, if you want to do the correction for your modeling, what tool you have to follow, set display option, selection deselection option, one story, similar story, all story option, editing command is there, load assignment command is there, material definition, section definition commands are there. But these all commands might be known to you, but we are going to learn these all commands deeply with a practical approach. View option is there, snap option is there, what are their applications, setting for the coloring, setting for the elements, everything we are going to cover in detail in the section of important commands for practicing smartly in your CSI ETABS software. That also will be the part of your beginner level. And in the beginner level itself, we are going to take one simple dummy project. Okay, and the objective of this simple dummy project is to make you all confident with the software for the modeling, for the load assignment, for the analysis, and we will get more confidence with the software. In this way we are going to complete our beginner level, and after the completion of the beginner level you will be definitely confident to use the software. And after that we are moving towards the intermediate level, and in our intermediate level we are going to deal with the one real example projects, and the objective of this intermediate level is to give the real exposure how the structural engineers are dealing with the real example projects. So very first thing we are taking one real example project of the architectural drawing. That may be of any metropolitan cities project, it may be of Bombay project, it may be of Hyderabad project, it may be of Bangalore project, it may be of any Pune city project. So well known and metropolitan cities project we are going to take, and that we are going to deal in our training program. So it will not be a dummy simple project. So definitely if we are going to deal with the real example project, so challenges will be there, and if the challenges will be there, then will be the actual learning. So very first thing, this kind of project we are going to take, as you can find it, it is not the simple one, these are the real projects. And we have to understand how to read this architectural drawing, because if you are not confident, if you are not knowing the way how to read the architectural drawing, you cannot go for the modeling, you cannot go for the analysis. The very first thing is to understand the architectural drawing, to read the mind of the architect, and to read the mind of the architect and owner you need to read the architectural drawing. Sorry. So it is what very first we need to understand the architectural drawing, and after the understanding of architectural drawing, guys, the next important thing is to decide the preliminary sizes of the element. What should be the preliminary size of the beam, what should be the preliminary sizes of the column, what should be the preliminary sizes of the shear wall. Without of deciding the preliminary sizes of the element, you cannot proceed for the modeling, you cannot proceed for the structural framing plan. And we have made our book of practical guide for designing of reinforced concrete structure by using ETABS, RCDC and Excel. So in the light of all the recommendations were made by this book of practical guide, we are going to discuss all the important points were recommended by the experts to decide the preliminary sizes of the element, and we are doing the simple calculation with the help of spreadsheets. So with all of these combinations we are going to decide the preliminary sizes of the element. And once the preliminary sizes of the elements were decided, the next is to decide the positioning of the column, next is to decide the orientation of the column, orientation of the shear wall, positioning of the shear wall. That is another important thing. So on what basis we have to decide the positioning of the column, orientation of the column, and also applicable for the shear wall, positioning of your beams, positioning of your slabs, how you can decide it. So that also written in your book of practical guide in detail point wise. we will learn in the light of this book of practical guide, and then we are going to prepare our structural framing plan. What does mean the structural framing plan, why it is important this structural framing plan, what are the different types of structural framing plan, this all we are going to learn in detail in our training program. And with all of that studies, we are going to prepare our structural framing plan. And after the completion of structural framing plan, you have to move towards the software. You have to initiate your work with the software, and when you are going to look for the software, the very first thing is to draw your grids. You need to have the reference line. What does mean the grids? What is the need of this grid? Actually, it is the need to have the reference line in the ETABS software to initiate your work for the purpose of modeling. If you are not having the reference line, what is happening? You are going to do the mistake while the modeling, and if your model will be wrong, your entire next things will be wrong. That your analysis will be wrong, your design will be wrong, your scheduling will be wrong, your detailing will be wrong, everything will be wrong, because your model is wrong. And your model is going to become wrong because of wrong initiation. So you have to draw the grids in the ETABS software effectively. So there are three methods to have the grids in the ETABS software, or the reference line in the ETABS software. Very first is the offset point method, second one is the ETABS template, and third one is your export import method. So under which situation, under which circumstances you have to use a particular option among these three options. Either you have to go with the offset point method, either you have to go with the start template, either you have to go with the export import method. With which option you have to initiate your work, that is very important to understand and learn. So if your geometry of the structure is very much complicated, then you have to go with the export import method. When the geometry of the structure is simple, symmetrical structure, orthogonal structure is there, easy to draw the grids over the architectural or structural framing plan, then it is better to go with the ETABS template. And when the structure is very much simple, then you have to go with the offset point method. So these are the three methods. So practically for our real project, we are going to discuss all of these methods in our beginner level as well as in our intermediate level. We are going to learn it. Okay, now the next point we are going to see here, the modeling. So now modeling is not a difficult task, but smartly modeling is very important thing, because at a time you are not responsible to deal the one project. At a time multiple project you have to deal with. So how smartly to do the modeling of the column, how smartly to do the modeling of the beam, how smartly to do the modeling of the floor slab, how smartly to do the modeling of the staircase, how smartly to do the modeling of the shear wall. How you can take the help of the CAD software to do smart modeling, how you can directly import the 3D model from the CAD drawing to your ETABS software. These all smart things we are going to learn in our training program in detail. And guys, we have to learn about the concept of the moment release, we have to learn about the concept of the shear releases, torsion releases, what does it mean, how to implement in the software, everything we are going to learn. Okay, and thereafter we have to do the application for the loading. Okay, so there will be the different types of the loads to which your structure is going to be subjected. Gravitational load, lateral load, in gravitational there will be a dead load, superimposed dead load, live load will be there. So which codes are there, how to find out that loads based on the application of the building or structure. If it is a residential building, loading type will be different. It is commercial building, loading will be different. It is institutional building, loading will be different. Okay, so that we are going to learn. If suppose you are going to apply the lateral load as wind load and earthquake load, so how to use the ETABS template for application of the lateral load when you are going to deal with the intermediate height of the structure. At that time we are using the ETABS template for application of the earthquake load, for the application of the wind load. But when you are going to deal with the tall structure, at that time we are not using the ETABS template for assigning of the load. We will discuss it at the advanced level. Okay, so how to do the calculation for the lift machine room, we are going to take the help of our Excel sheet. How to do the calculation for the water tank load, because your real project will be consisting of all of these things. Your real project will be consisting of lift portion also. Your real project will be consisting of the overhead water tank as well. Your real structure will have the parking area as well. So all of these loads you need to consider. You should have the skill to do the calculation, how to do the temperature loading calculation. Everything you need to learn in detail. And with these calculations we had to assign the load over our structure. We had to assign that loads to all to our structures, to beams, to slab, okay, to column, all this, to staircase. Okay, after doing all of this assignment of the loads, we need to perform the analysis. And guys, analysis is very important, because your entire design will be depends on your analysis. And when your structure is subjected to only the gravitational load, the analysis or the response of your structure against the application of the loading will be totally different. But when your structure is subjected to lateral load as earthquake and wind, then structural response analysis results will be totally different. So you should be very careful, and you should have the knowledge when the structure is subjected to gravitational load, so how the structural response will be. If your structure is subjected to lateral load, how the structural response will be, how the analysis results is going to be distributed. So if we are going to see here, actually we are expecting that when there is a column on both of the side of the beam, at that time what will be there, the bending moment diagram will be of like this. The bending moment diagram will be of like this. At the support there will be the negative moment, at the support there will be the negative moment, at the middle there will be the positive moment. But when you are going to see this analysis results, at one point there is a negative moment, at one point there is a positive moment, at one point there is a positive moment, negative moment, a positive moment, negative moment. And second thing, we are expecting that maximum positive moment at the middle, but here we are not getting the result accordingly. Why it is happening? Because this structure is not subjected to only the gravitational load, this structure is subjected to lateral load. And when the structure is subjected to lateral load, your beam or your column will be subjected to reversal action. What does mean the reversal action? That we are going to discuss in detail in our training program. How the reversal action and stress distribution is going to affect your design, that we will have to see. And then we have to ensure whether the analysis is properly executed by the software or not. Sometimes software is doing the mistake, or sometimes we are doing the mistake. So we have to correct ourselves as well as we have to correct the software. So both of the things should be what checked, whether all the loads are transferred to the supporting member or not, whether the load is going to be distributed properly, because in column the axial load is going to be transferred from top to bottom, and at the bottom column maximum force will be there, on the top column the less force will be there. So whether it is right or wrong, we have to look at the response of the structure under the gravitational load, means deflection, under the lateral load the deflection, the stress distribution in your floor slabs. Diaphragm concept you have to implement here, because your structure is going to be subjected to lateral load. That diaphragm concept we are going to deal in detail in our advanced level. So this part is also going to be covered, and this is what shear force, torsion. So if you are going to see here on the left hand side, shear force distribution in each of the beam is present, and on the right hand side there is no torsion. So why the torsion is not present? Because we have released the torsion. Why we have released the torsion? Because there are two types of the torsion, primary torsion, secondary torsion. So what to do with the primary torsion, what to do with the secondary torsion? So in the light of our book of practical guide, we are going to learn all of these things in detail. That comes under the validations of the results of your ETABS software analysis results. And after doing all of these studies, we have to move towards the design part. And guys, design is very much interested in the ETABS software, because before of going for the design you have to do the lots of settings in the ETABS software, and based on these settings, these preliminary settings, the design is going to be executed. So people sometimes what they are saying, whatever the things is actually present here, let it to be as it is and proceed for the design. That is not the right way. You have to learn each and every point. If suppose the minimum eccentricity is there, if I am going to choose it as yes, if I am going to say it as no, so what will be the impact on my design results? There is an additional movement. What is the concept of additional movement? Either your column is going to be affected, either your beam is going to be affected, either your shear wall is going to be affected, either your floor slab is going to be affected. What is happening when to perform the P delta analysis, when it is not needed to be considered? So this is what to learn. What is the load pattern lie load reduction pattern lie load factor? This is again very important. If you are going to understand this, you can make your design more economical, because it is giving the option to reduce the load, but we are not knowing about this command, this option, whether you have to go with the ordinary framing system, ductile framing system, sway sway frame system, lie load reduction factor. What is the importance of this lie reduction factor? We are discussing this point in detail in our advanced level. What is the bracing, what is the unbracing, effective length factor, global axis system, stability index factor, Q factor, because the design of your columns depends on this effective length factor, stability index factor, eccentricity consideration factor. So this setting is very important. Design is not important, because design is going to be done based on this setting definition, these definitions. So if you are not sound with the understanding of all this definition, definitely your design will be wrong. So you have to learn all of these things, and after setting out all of these things, you have to move towards the design, and this will be the chart for the designing of your frame. If your framing is ordinary, if your framing is ductile, if your framing is non-sway, so based on that, how your software, ETABS software, is going to design your frame, it is what the chart is defining. So I am discussing this chart in detail in our training program. Very important chart. If you are understanding this chart, lots of problem is going to be solved. If you are not understanding this chart, then it is very difficult to understand the design of the frame in the ETABS software. Frame means your beam, column, shear wall and everything. So it is important to understand this chart. Okay, so this will discussing in the training, because here we are not having enough time to cover all of these things. That's why I'm just giving the overview. Okay, so after this we are finally going to design our structure, and after the completion of the design, again just like of your analysis, we have to check the design result as well, whether the design is correctly has been done by the software or not, whether all the members are passing the design check or not, whether the demands of the reinforcement as per the codal recommendation or not. We have to validate all of these things, whether all the members were designed properly or not. Is there any problem with your design or not? If there is a problem, then what will be the solution? That also we need to look at. Okay, whether all the member passing the design check or not, for the beam, for the column, for the shear wall, for every element. And after that, sometimes the people are complaining that, sir, on the top floor we are getting the more reinforcement demand, and the lower floor we are getting the less reinforcement demand. Why this is happening? That I am going to answer in our training program in detail. Okay, and like this is a one simple problem. Likewise, hundreds of problems will be there, hundreds of challenges will be there. This is a one simple common challenge I am sharing with you. This is not only, likewise I am telling you, hundreds of problems will be there at the structural framing stage, at the analysis stage, at the design stage, at the load calculation stage. That all are practical. If you are taking the dummy project, no, that there will be no any problem. That is the dummy project, simple project. But when you are going to deal with the real projects, so hundreds of the real challenges will be there. And with this we are moving towards, if suppose any member is going to fail, if you are going to design, for an example, suppose column is going to fail. So I would like to ask a question with you all guys. Just let me know, if suppose any column is going to fail, so what you will do this solution? As a solution, what will you suggest? Tell me guys fast. If suppose any column, any beam or any of the element is suppose going to fail, so what will be the solution? Tell me fast, hurry up, hurry up. I'm just looking at your response. Just write in the chat box fast. Section change. Okay, increase the size of the column. Okay, very good, very good. Increase the size of the column. Section size and orientation, very good. Orientation also, very good, very good. Increasing the percentage of reinforcement, very good. That's also the one solution. Please guys, just write in the chat box, hurry up. I'm looking at your response, please. Narendra says that structure will fail. I'm not getting what you are saying. Just write in the chat box, please, everyone. Torsion value should be 0. Okay, so many reasons. Okay, so most of you are recommending that we should have to increase the section size, we should have to change the orientation, we should have to change the percentage of reinforcement. That all are correct, but these all decisions were made later on. The first thing is that you need to find out the problem. What is the problem of the failure? That is the important thing. People are doing the mistake. They are getting the failure, they are increasing the size again and again, again and again, again and again. And in the beginning I have given the example, the people are doing the G plus 2 floor building, and it is a small residential building, and for G plus 2 floor building they are providing the size of the column 230 by 800. This is required for like 10 to 15 floor building, and that size you are going to provide for G plus 2 floor building. Why? Because you are not understanding the cause of the failure. You are not going to diagnose the problem, and without of diagnosing the problem you are giving the solution. This is the important thing. So how you can diagnose the problem, how you will come to know what is actually the problem of the failure? Either your column is going to fail in the axial load, either your column is going to fail in the flexure, either your column is going to fail in shear. What is the cause of failure? Either your column is going to fail due to the sectional means geometrical failure, means short column long column effect. What is the cause of failure? That you need to know. Either it is going to fail in the earthquake loading, either it is going to fail in the wind loading combination, either it is going to fail in the gravitational loading combination. You are not going to know the problem. Either everything is okay but the orientation is wrong, modeling is wrong, analysis is wrong. So you are not going to diagnose the problem, directly going to give the solution. So guys, you have to look at the reports of the calculation were done by your or given by your ETABS software. Unless you are not reading the report, you cannot give the solution. So you should have to understand the algorithm of the software. This part is also covered in the beginning. This is the algorithm. You need to able to read the report of the ETABS software. Then you have to validate the results in respect of the percentage demand, whether your whether your software is following the codal recommendation or not. If you were specified the code to be followed as IS 456 in the ETABS software, so in ETABS software we were defined the code should be followed as IS 456. So whether your software is going to follow the IS 456 or not, whether the demand of the reinforcements are within the limit or not, this you have to check. Okay. And guys, at many of these stages we need to take the help of spreadsheets for the validations of the results of the software, for the designing of the different elements individually apart from the ETABS software, to check the result whether the software has did the right design or not. So we have made our own well customized smart excel sheet. By one excel sheet you can design all types of the slabs. By one excel sheet you can design the foundation. By one excel sheet you can design the all types of the beams, all types of the columns. You just have to put the analysis results values in this excel sheet, and sheet will able to do the complete design. We have the many sheets for doing the load calculation for the tall structure, for the earthquake, for the wind, for the overhead water tank, for the lift machine room. Okay, so these all excel sheets is also going to be covered in this training program, and you don't need to ask. This excel sheet is going to be shared through this training program to all of the participants. So whatever the materials we are going to use during this training program, that all materials is going to be shared with you all guys, including of the architectural drawing, model files, and learning materials as PDF, as excel sheet, practice materials, everything we are going to cover in this, and we are going to share through this training program. Okay, and after that we have to do the optimization in the design. Structural engineer's responsibility is not just to do the design. It is not just to do the design, you have to do the optimization. Let's take an example. Suppose you are going to deal any project, and suppose you are the one person and I am also one person going to deal the same project. And if suppose I am going to do the design, and I am going to end up with a demand of the reinforcement as about to 1000 ton of the reinforcement is required for my complete project. And you are going to do the design the same project, and with your design the demand of the reinforcement is suppose 1500 tons. My demand is 1000 ton, yours is 1500 tons. So whose design is going to be accepted by the client, by the architect? Can you tell me fast? 1000 ton. Okay, obviously, because the client and architect is not knowing about the structural design. Their concern is about the cost, their concern is about the economy. They are not going to see how effectively, even though it is possible that you might have design with more safety, your structural design is safe, good, okay, you have taken the more safeties, but your design is not going to be accepted. My design is going to be accepted. Why? Because cost effectiveness. So client and architect is not going to look at the design. Your client and architect is going to look at the cost. Their consideration is only about your cost. So how to do the optimization in design effectively? Reducing the cost doesn't mean to do means unexpected thing, unwanted things. Okay, so otherwise your stability also will be in danger. You will say that, sir, I will make the design with 500 tons only. I will reduce the number of columns, I will reduce the sizes of the column, I will reduce the percentage of reinforcement to a greater extent, I will use the very low grades of the concrete which is not suitable for the structure. So my cost will be 500 kg, 500 tons only. The cost is going to be reduced by 3 times, 2 times. So your stability, your serviceability will be totally in danger. That is again in problem. So how effectively to do the optimization in respect of the code consideration? Okay, you have to properly follow the code. By using the codal recommendation, how you can reduce the sizes of the column, you can reduce the loading consideration, you can reduce the live load reduction factor for doing the optimization. So there are lots of points given in your IS codes to do the optimization, so your cost of the structure will be reduced. That also we are going to do in our project. And with that we are going to complete our project, and thereafter we have to do the detailing. And detailing is again the one important stage and step, detailing and scheduling. And in our training program we are going to discuss the detailing and scheduling 2 times, not 1 time. We are going to discuss it 2 times. How? I will let you know. After getting of the design result from the ETABS software, we are going to do the detailing scheduling by manual approach, means in the CAD. And we are going to prepare the report, design sheet, and all these things we are going to do in the light of the codal recommendation ISSP 34. That is well, there is discussion of detailing in a well detailed manner. Okay, for the beam, for the column, for the slab, for the shear wall, for the staircase, for every of the element there is a detailed discussion, what material property, what diameters of the bars, or the positioning, curtailment, development length, cranking of the bars, everything is there. We are going to do the study of the codal recommendation, then we are going to execute it here. And after all of these studies, we are going to finally prepare the schedule. But guys, here is one important problem. If in real, if suppose you are going to do the scheduling and detailing for G plus 5 to 10 floor building, okay, and even if it is low floor but it is a big project, so if you are going to do the scheduling and detailing, it takes hell lot of time. And as I earlier said that at a time as a structural engineer, you are not responsible to deal one project. At one time you have to deal with the multiple project. With a short period of time you have to complete and give the delivery of the design report in a short period of time. But if you are going to do the scheduling and detailing manually, so it will take hell lot of time. It is not possible to complete the project with scheduling and detailing and design report uh, within a given timeline. So we need to look at any tool that will help us to effectively and quickly prepare the schedule and detail. That is what your STAD RCDC software. To solve the problem of the time, there is a what solution? Your STAD RCDC. This is a very powerful software for doing the quick detailing and scheduling. So whatever the time you are going to complete in 2 to 3 days, that time is going to be completed in just of 30 minutes to 1 hour when you are going to use this STAD RCDC software. So whatever the detailing we did or scheduling we did manually, that same we are going to repeat with RCDC software. And in this RCDC software, again we have to understand the user interface, we need to understand the algorithm of the software as we did for the case of ETABS software. So we are not directly going to initiate the project. We will let you know first how to operate this RCDC software. Okay, application of this RCDC software, history of this RCDC software. Then we are going to link your ETABS and RCDC to do the all design, how to export the result from ETABS, how to import your result in RCDC, and what points to be controlled for the medium rise structure, for the tall structure, for the simple structure, for the complicated structure, for orthogonal structure, for non-orthogonal structure. For all categories of this structure we are going to do the discussion. And with that we are going to do the design for the beam, for the detailing. See, if you are going to do this kind of detailing in the CAD, so what time will be required? But by the help of RCDC, in just a single click, in few seconds, in few minutes, this report is going to be generated, not for one beam, for thousands of the beams, for thousands of the beam. Okay, and doing all that things manually is next to it's very difficult actually. Okay, and likewise we have to do the design, scheduling and detailing for your column. People are complaining that the results of the RCDC is not going to match with your ETABS because they are not understanding the algorithm. If you are not good sound, if you are not, your base is not sound with the algorithm of the softwares, you cannot effectively use, you will not able to match the result, you cannot control the results of the software. It is actually important to control the results of the software as per our demand, as per the codal recommendation. So how to control that, we will discuss it. Then detailing for the column we are going to do by the RCDC software, and likewise we are going to do the design completely by your for your floor slab. And see, this kind of detailing you are getting by the RCDC. And finally we are going to do the design for your foundation, for the pad footing, for the sloped footing, for the stepped footing. How to do it? In our training program we are going to do the foundation design by spreadsheet by your RCDC software. Okay, and these all studies we are going to do in the light of the book of practical guide, where all the stages written in a detailed manner. So there was explanation in detail. Okay, and this book of practical guide will also going to be shared with all of our participants, those who are going to participate in this training program. and in that way we are going to complete our intermediate level. And I'm confident that after the completion of our intermediate level, our participant will be confident to deal any of the real project of medium rise. Okay, after that we are going to start our advanced level, and in our advanced level all the advanced things we are going to cover which is not covered in your beginner level, which is not covered in your intermediate level. So all that things we are going to cover in our advanced level. And when you are going to prepare the structural framing as we did in our intermediate level as well, but here the things will be different. When you are going to deal the tall structure, there we have to think about the stiffness, there we have to think about the ductility, there we have to think about the strength at the time of the framing, more importantly. And if your structure is the tall structure, how to decide the positioning of the shear wall, how to decide the positioning of the how to decide the orientation of the shear wall. You need to know the stiffness of the structure in a particular direction, center of mass, center of rigidity, to avoid the torsional irregularity over the height. So these all things is very important to understand when the structure is subjected to lateral load in addition to your gravitational load, that we are deeply going to understand. Then methods of analysis. What are the different methods of analysis available? Static analysis and dynamic analysis. In static analysis, equivalent static method is there, and non-linear pushover analysis is there. In dynamic, linear analysis is there, non-linear analysis is there. There will be detailed discussion of each of the methods of analysis, and then we are going to perform the static and dynamic for our proposed tall structure. So these studies will be there in detail. After that we are going to do the manual calculation by the static, by the dynamic. We are comparing the results, and then also we are going to execute in our ETABS software for the purpose of validation for our tall structure. Then for when your structure is going to be subjected to wind loading, and it is supposed tall structure 20 floor, 30 floor, 40 floor, so whatever the number of floors are there, based on that we have to do the calculation for the wind load by the help of the spreadsheet. So how do the calculation for the wind load, that we are going to study basically from the reference of IS 875 part 3, and doing that calculation by the Excel sheet, and then we are going to implement in the ETABS software. Okay, and what is the meshing concept? What is the finite element based approach for the designing of the structure? Because all of the softwares are mainly based on the finite element based approach for the design. So what is the conventional approach, what is the finite element based approach? And if you are going to do the meshing, so how the results are going to be improved, how the results are going to be changed, to what extent we have to do the meshing, that also we are going to learn. And stiffness modifier, this is again very important point. Stiffness modifier, IS 16700, IS 1893 is recommended to consider the cracked analysis. What does mean the cracked analysis? What is the uncracked analysis? What is the combination with the cracked analysis and uncracked analysis? How to define the property modifier in the ETABS software? So we will learn first the basic concept, okay, about the stiffness modeling, cracked analysis. Then we are going to implement in our ETABS software. Then we are going to look at the result in your design, how it is going to affect your design, whether design is going to become heavier, whether the design is going to become lighter, what is happening. So we are going to do the study for the property modifier, for the beam, for the column, for the slab, for the shear wall. Stiffness modifier, property modifier, strength modifier, these all modifiers we are going to implement. So we will give a proper explanation, proper notes, proper implementation in the software, and conceptual understanding will be there, not just a definitions. Then live load reduction factor concept. What is the live load reduction factor? How to implement in your ETABS software for the live load reduction factor by the tributary area method, by the manual definition method, how to define it manually in the ETABS software, and how it is going to impact the design result, whether your design is going to become heavier, whether your design is going to become lighter, that also going to be covered in this training program. And then we are going to understand about the load combination. If we are going to deal with the structure which is subject to only gravitational load, so load definition only will be limited, load combination will be limited. But when your structure is subjected to lateral load, when the structure is what, orthogonal, non-orthogonal, so how to define the load combination in your software, which code is defining that, that all we are going to learn in detail in our advanced level. I will show you every load definition, load combination definition, mass source definition, when the structure is subjected to live load less than of 3, more than of 3, how it is going to be affected, that we are going to discuss. And most important is your Moodle analysis. What is the definition of your Moodle analysis? Moodle mass participation ratio, what is the definition, why the Moodle analysis is important, what is the P delta analysis, why it is important, when to perform, which code is asking, how to implement in the ETABS software, how to look at the result. See, suppose the Moodle analysis you are going to perform, so our IS code is recommending that your first mode should be free from torsion, your second mode should be free from torsion, your third mode should be free from torsion. So it is the most important stage for the tall structure to make structure free from the torsion. So what is the codal recommendation for the mass participation, for the fundamental time period, for the frequency, for the torsional irregularity, that all we are going to learn in detail in our training program. And next to that, we are going to do the buckling test. You might have heard about the buckling analysis for your column. We are going to design our column such that it should not buckle, it should be safe in flexural stresses, it should be faced in the lateral stresses. Likewise, the same analysis we have to implement for the tall structure. Buckling analysis check we need to perform, buckling check we need to do, buckling factors you need to find out. So it is again very important to do for your tall structure. And next we are going to perform the maximum lateral deflection check, maximum drift check, story drift check, that all also going to be performed in this. So we are going to do the established check in reference of your codal recommendation. So all these parts is going to be covered in your advanced level for the tall structure of more than of 20-30 floor. So this will be the complete part of your advanced level. Okay, so after the completion of our advanced level, our participant will be confident to deal for the tall structure, especially for the modeling, complicated analysis and complicated design, and you will be able to deal any tall structure. So this will be our advanced level. And whatever the projects we are going to complete in our training program, we are going to prepare the report, we are collecting the results, we are getting the we are giving the task. Once you complete it, on behalf of you, we are going to prepare the project completion report, and that project completion report will help you all to get your dream job, to get your placement in any of the MNCs or design firm. So that also we are going to help, we are going to help you to prepare your design portfolio. Okay, so this design portfolio will be there. And after the completion of this training program, you will get book of practical guide, bunch of all the spreadsheets, your certification, your uh, uh, design portfolio, project completion report, and definitely no one will be able to catch you to get your job, get your placement. Okay, and let's talk about the pricing of this. So basically the people are charging for beginner level just about 8 to 20,000 for just about the beginner level. They are going to talk about the dummy things, just about the commands of the software. If you are going to learn the real projects, they are charging about to 1 lakh rupees. And if you are going to learn all the advanced things, complicated things, the people are charging more than 1 lakh rupees. But all these three levels, we are going to cover in just of 5,999. Okay, in our training program we are going to cover all of these three levels, where you are getting everything, every material, every learning, every concept, everything in just of 5,999. No one will give you all these things in this cost. This training program will be for 2 months. The duration of this complete training program will be for 2 months. Every day that our classes will be live classes, live interaction will be there for 1.5 hours from 7:30 to 9. You can come, you can attend the class, you can ask your doubts, problem, questions. We all together will do the learning and we'll do the completion of the project. We'll prepare the report, okay, and we'll do the learning. Till now we have trained to more than thousands of the professionals, beginners, and they are working well in their field after learning it. You might have seen in the beginning the what our students are saying, what our participants are saying. So the recording will be there, and you can interact with us anytime. You will get the real example, real projects, and after the completion of the project, all the things you are getting, I already have explained. So those who are really interested to join this training program, okay, so the link is available in the chat box. Link is available in the chat box. You can proceed with that link and you can complete the enrollment directly. You can proceed with this link, or otherwise you can visit our website StructSoftCentre. You can search on Google, it is available, and you will land to this particular page and you can do your enrollment here. Okay, so it is better to follow the link given in the chat box. In the chat box the link is available. By just clicking over that you can complete your enrollment. So hope that you all understood what points we are going to cover in this training program.